Hello everyone, welcome to the next video in AZ-300 series, and today we are going to talk about Azure Site Recovery Architecture, which includes the components which are involved and how the replication happens and how you can utilize this for migration or disaster recovery purpose. Okay, cool. Well, Azure Site Recovery is a part of service that we create Vault for, if you remember, recovery service Vault. So under recovery services, we have two services. Backup we have already covered, and now it's the site recovery. Okay, and site recovery we can use for uh, migration purpose as well, but ideally it was made for BCDR solution, business continuity disaster recovery solution. Okay, so before we go ahead and perform the lab, it is always better to understand the architecture, understand the component, and understand the process. Okay, so let's get started. So let me try to create the mind maps here, the architecture, which will help us to understand the architecture better, the process better. Okay, so this is our, let's suppose, on-premises, on-prem environment. Okay, and we have cloud environment here. Okay, here we have our Azure environment. Azure. Okay, cool. Now in on-prem we have certain VMs running. All right, VM, and we need to move these VM to the Azure, or you gotta create a disaster recovery plan. Well, ideally, both the process are absolutely similar, but in case of migration, we don't fail back. We just fail it over and shut down the on-premises machines. But in case of disaster recovery, we fail back once the disaster is finished or you have taken care of the other uh, measures. Cool. So here we are trying to understand the architecture for ASR, and to understand the architecture, we gotta know the components involved. Okay, so let's start with the Azure first, because you need to create Azure Recovery Vault first, and then you gotta create the ASR infrastructure for on-premises or VMware or Hyper-V. Doesn't matter what the source environment is. ASR supports all. Even if you have AWS or any other cloud as a source environment, ASR supports that as well. Okay, cool. So what we need on the cloud side, the very first thing is we need virtual network, and we need site recovery vault, and we need storage account, okay, to keep the data which is coming from on premises. So let me write it down. We need a storage account as in prerequisite. Okay, we need a vault, recovery vault, to prepare the infrastructure. Recovery vault. All right, and we need VNet, where you gotta place your machines after failover. Okay, cool. Now, when you started creating the infrastructure with the help of recovery, once you create the recovery vault, there are options, site recovery infrastructure, and you create infrastructure. We'll see everything in the lab. Just try to understand the architecture first. At that particular place, we can download the setup that we need to set up for what? Let's understand this. Setup for configuration server, process server, and master target server. These are the components that you need to have on the source environment. If you have a VMware, you can download the template and deploy the OVF template to deploy a machine which would act as an this configure server, process server, and master target server. Okay. In case of physical machine, you can simply use it as a you can download the config server, you create a machine there, and you install it, your config and process server there. Okay, so what are the components? Let's try understand the structure first. So what are the components needed on the on-premises? Let's write those down. We needed three components. Okay, I need to make it in such a way that it would start make sense more. So let me create a single server, because this machine where you install the config server and process server is actually a bigger machine. It has its own prerequisite. We'll talk about that as well. So let's put it here, put it here. Okay, we have config server, we have process server, and we have master target server. Okay, and you can simply call this management server. Okay, which involve these servers. Let me write this down here. Management servers. Okay. Ideally, process server and master target server installed on the config server all are on the same machine. That's why I put it in a single box. Okay. So this is the prerequisite as of now. We need these three things on the Azure, and on the on-premises we need config server, process server, and master target server. Okay. Now we need to understand how things work here. Okay, we need to understand each and every component. So we know why we need VNet, because failing over the machine needs virtual network. This is what it stands for. Recovery service vault holds the infrastructure for ASR. Storage account is the cache storage. Whatever data is coming from the on-premises going to store here. Okay, and what these things are stand for, let's try to understand that part. Okay, so a config server is actually a centralized management is done by the configuration server. Okay, Let me write this down here to start make more sense. Centralized management. Okay. All right. So how this centralized management? Because config server coordinates communication between on-premises and Azure and manages data replication. So what is actually happening here? Let's try to understand this. This is config server. This is what it do. So what it is doing from here, it's moving to Azure, taking care of communication and data replication, manages data replication to the Azure. This is what the configuration server do. Now let's talk about the process server. Process server is used for caching, compression, and encryption. Let's write this down. Come on. Caching, compression, and encryption. Okay. Encrypt. This is what it does. Now, this process server. Okay. So this process server receives replication data from the machines enabled for replication. These machines will send data to the process server once they are enabled for the replication. It optimizes replication data with caching, compression, and encryption and send it to Azure storage. Okay. It also performs a push installation of mobility service on on-premises VMware virtual machines or physical server that you want to replicate. It also performs automatic discovery of on-premises machines. Okay, this is what the process server does. It also push mobility agent. Come on. All right, and this master target server is for failback. It handles replication data during failback from Azure. So it is needed for failback. Failback purpose only. Okay, cool. So hope this started making sense now. So let me try to do this. These VMs sending data to process server. Okay. VM sending data to process server on port 9443. This is the important part, and this particular port is customizable. You can change it. Okay, cool. And this configuration server talks to Azure on port 443 HTTPS and talks to these virtual machines on the same port 443. Okay, cool. Now let me create this. Let's suppose this is the mobility agent, and this process server, install it on the VMs, a push installation. Okay. Now this, let's try to understand the replication process now. We understood the config server, process server, master target server. Okay, and there is a little prerequisite to install config and process server. It is like on the VM where you're installing these servers, it should have 4.6 or later .NET framework, and if TLS 1.0 is disabled, make sure 1.2 is enabled. It should have CPU cores 8 and 16 GB of RAM. Number of disks, if you're doing only the migration, you need 2 disks. One is the OS and the free disk of 600 GB at least, because it would act as a cache storage on the source side or the on-premise side. And if you are also planning for DR like master target server, then you need one more disk of 600 GB so that it would hold the data coming from the Azure. And if you talk about the operating system, 2012 R2 and later 2016 works. Okay, and this server, this VM should not have any Active Directory domain services or IIS services installed already. IP address should be static, and 443 and 9443, these ports that I mentioned, should be open. Okay, and there are number of other requirements that you can see. I'll share the link in the description box, and it should connect to the internet. If you are using, if you cannot, then there are certain URLs that need to allow so that it could talk to the Azure storage, and that's on the public side, so the data transfer happens over the internet. But don't worry, it's encrypted and compressed. But you can also use Microsoft peering express route, not the private but the Microsoft one. Okay, good. Now let's try to understand the replication process. When you enable the replication for a VM, initial replication to Azure storage begins using the specified replication policies. So that means there is something I need to mention here is we need a recovery vault, storage account, VNet, and while you create the infrastructure, ASR infrastructure, you also need to create the replication policies. We need one more thing, which is called replication policies. Replication policy. Okay. And this replication is block level, near continuous, using the mobility service agent running on the VM. This can be usually pushed by process server. You should have the credentials which has the rights to push or do the installation on these VMs. Okay. In certain cases where you cannot do that, then you can install manually or you can deploy with the help of SCCM as well. Now, this replication policy we define certain things. When we will create, you will see. Okay. Uh, and by default, every 5 minutes, the crash consistent snapshot goes to the Azure storage from your own premises, and app consistent snapshot can be taken every 1 to 12 hours depending on your app needs. Snapshots are standard Azure blob snapshot, and the mobility agent running on a VM requests a VSS snapshot in accordance with this setting. Okay, so every 5 minutes crash, every 1 hour app by default, but you can change the app consistent as well. There is settings like RPO threshold, recovery point retention. These settings does not affect the replication. It helps with monitoring. An event is raised and optionally an email is sent if the current RPO exceeds the threshold limit that you specify. Okay, and this recovery point retention is more like how far back in time you want to go when a disruption occurs. Maximum retention on premium storage is 24 hours. On standard, it is 72 hours. Okay. And I've told you already, the replication traffic replicates to the Azure on public internet. This is actually not this. Let me put this. Where did it go? I used it. Right here. So this is public internet or express route. Okay. Replicating traffic over a site-to-site virtual private network from on-premises site to Azure isn't supported. And after initial replication finishes, replication of delta changes to Azure begins. Okay. And whatever track changes for a machine's replication sent to the process server, it will send to the cache storage in the Azure. Now, if I talk about the communication, it has already been discussed, but let's go over it again. It is very important. VM communicates with the on-premises configuration server on port 443 to the configuration server. Okay. The configuration server orchestrates replication with Azure port 443. VM sends data to the process server on 9443. This port can be modified. Process server receives replication data, optimize, encrypt, and send it to Azure storage on 443. And this replication data logs first land in cache storage account in Azure. Okay. These logs are processed and the data is stored in Azure managed disk called as ASR seed disk. Azure managed disk called as ASR seed disk. And recovery points are created on that disk. Cool. So this is a basic understanding and architecture overview for ASR. It could be physical, it could be VMware, it could be Hyper-V. The process is absolutely the same. If it's a VMware, you can deploy these things with the help of OVF template. And if it's a physical, you can do it manually. You can build a virtual machine and run these servers. Okay. So this is all about it. Let's try to do the demo part in the next video. Thank you for watching. You have a good day. Bye-bye.